Hello everyone. Now in this lecture we will know about the next unit as a database transaction and a query processing. In a previous unit as under the unit 3 we know about the normalization or the database relational database design. Now we will know about the what exact the transaction under the database. Firstly, basic concept of transaction. Collection of operations that form a single logic unit of a work are called the transaction. Simple, it may be the different type of operations, set of operations. We can say that this one is a one transaction, right? It contains again the set of operations. Now, a database system must ensure proper execution of a transaction or depict failure either the entire transaction executes or none of the it does. Now the database system must ensure, database system means the program which one is handle the database, which one is ensures that if this transaction is executed successfully or not, or it may be executed partially That is the situation the particular database system print or it may be ensures properly about the transaction. Furthermore, it must manage concurrent execution of transaction in a way that avoid the introduction of inconsistency. Means if we want to when we run the transaction it may be executed wholly or it may be totally executed and update the database okay, is the one case it's executed properly and update the database. It execute first step, then first scenario, then second scenario it execute halfly and then update some data under the database. Then it is not a situation with a proper transaction, right? It comes with the inconsistency. That's why if the transaction execute successfully or it may be a whole transaction execute successfully or nothing will be going to change with the help of this transaction. That is only a two cases, and this scenario which one is managed by the database system. Database system must ensure proper execution of transaction. It verifies the failure either the entire transaction executed or the none of it does, right? Now the furthermore, after the transaction it manages the concurrent execution of a transaction, like at a time two transaction run as a T1 and a T2, right? It's a concurrently executed on a single database. That one is this, right? Now in this scenario it manages the concurrent execution of transaction. The database system manages the concurrency, who one have authority to update on a particular time, right? That one is simply the manage the concurrent execution transaction. That we take a simple example of a fund transfer from one account to another account. That one is simply the transaction type, right? We normally says that one is a money transaction, right? That one is a one type of a transaction which one is update the databases. Transaction concept is a unit of a program execution that access and possibly update the various data item. That is the transaction. Transaction is delimited by a statement or the function call of the from begin transaction and end transaction. Means when we write the transaction it's starting with the syntax about the begin the transaction or end transaction. It's in between that the transaction is the transaction code is or the logic is available. The transaction consists of all operation execution between the begin transaction and end transaction. That is simply a basic concept. Now this is the transaction definition. Now what exact the transaction management? Transaction is a collection of operation that perform a single logical function in a database application. Like if we go with this transaction 1, update the roll number or update the name of roll number 1, right? Name of roll number 1. That one is, we can say that one transaction. Then each transaction is a unit of both atomicity and consistency. That one is it maintain the atomicity and the consistency. We know about the these 2 points explanation about this atomicity means what and the consistency means what. Now the ensuring the atomicity and durability property is the responsibility of database system itself. It's specifically of the recovery manager. Means to maintain the consistency and the atomicity, the recovery manager is helpful. Means it's again a software which one is maintain the situation, we can say that. Like when we transfer the money from account 1 to account 2, when we just for example it's a bank user 1, bank user 2. Now user 1 send a 1000 rupees to the bank user 2, and the balance of initial balance is 2k. Here initial balance is 1k. When the B1 sends a 1k to the B2, then updated balance is a 1k here and the updated balance is a 2k here, right? This is the final situation. But before this final situation, when the user transferred the 1000, it deducted the money and does not deposited in this account. In this scenario, the transaction manager or transaction management system manage the situation and it revert back, it recover this execution up to the in a initial condition, like a 2k of a user 1 and the 1k of a user 2, right? That one is simply the concept. In the absence of failures, all transaction complete successfully and the atomicity is achieved easily. If we complete the proper transaction, then we can say that the atomicity is achieved. Database system must therefore perform a failure recovery. If the something is failed, then it recovers it, right? With the same scenario. If the fail something here, then it recovers it revert back the amount in this account, right? Then perform failure recovery, detect system failure and restore the database to the state that exists in a prior condition. That is the example. Now finally, when several transactions update the database concurrently, simultaneously multiple transactions update the database, the consistency of the data may no longer be preserved. Consistency, that one is simple. Here we transfer the 1k, it deduct the amount and make it is a 1k, and it is not updated here, means it's a inconsistency of a database. Actually it come with the 1k and 2k, but it represent with the 1k and 1k. 1k is again the in between the failure. Now and because of that inconsistency happen. Now responsibility of a concurrent control manager to control the interaction among the concurrent transaction. Then this is again a software like a failure recovery, which one is recover the data if the failure happen. Concurrency control manager manage this type of a situation. Concurrent, if at a time two user like user 1 and user 2 access the database and access the same value, that is x. Both user 1 and user 2 access the same value x at the same time. Then this who one will access first, that one is managed by the concurrent control manager, right? To control the iteration among the concurrent transaction. Then transaction manager consists of the concurrency control manager and the recovery manager. Then transaction manager is again these two functions. That one is concurrency control manager and recovery manager, right? That one is simply the concept under the transaction manager. Then properties of a transaction, we require that the database system maintain the following properties. Then it's we can say that in short, database maintain the ACID properties. That one is ACID means what? It's simply the A for atomicity, C for consistency, I for isolation, and D for durability. That is the ACID, right? Database property of transaction should be maintained with these properties. Now we will know about what is the atomicity. Either all operation of the transaction are reflected properly in the database or none are. Means when we update the database with when we run one transaction one, the situation is like that, is the whole transaction executes successfully. That is the one situation, execute successfully whole transaction, right? Or none of the statement executed of a transaction one. It's a two situation. It may be the whole transaction is executed and database is update, or none of the action done by the T1. It revert back at the initial position. If it is happen, then we can say that the database is atomicity is maintained, right? Atomicity is maintained. Now consistency, execution of a transaction in isolation, that is with no other transaction execute concurrently, means isolation individually, we can say that, and preserve the consistency of the database. Just to go with the simple example, like if we want to update the same banking account example, one account contained 2k, another account contained the 1k. I want to transfer 1k from this account to this account. I just to transfer the 1k, but the database here 2k converted into a 1k, and here 1k converted into 2k. This is the final state, but it only changed this account details, it not changed this one, it still 2k. Then it may be the inconsistency of a database. It actual 1k, but it is again a 2k. It's an inconsistency of database. That is the consistency concept. It should be with a consistent, right? Now, or it may be the another example. If one database of a replica contained a 1k value, or another database replica contained a 2k value, it should be again an inconsistency situation. It should with a 1k. Now this is a consistency. Now isolation, even through multiple transactions may execute concurrently. System guarantees that for every pair of transaction T1 and Tj, it appears to a Ti or Ti to Tj, it appears to a Ti that either Tj finished the execution before the Ti started, or the Tj started execution after the Ti finished. Isolation means at a single time, single transaction work on the database, like a T1 and the T2 is the two transactions and the single database. Now when T1 is work on the particular database, then T2 is not allowed. If T2 is working on the database, T1 is not allowed. Means here we can say that isolated, individually the T1 is work or the T2 is work. That is the isolation, right? Transaction is thus each transaction is unaware of other transaction executing concurrently in the system, and then in this scenario T2 don't know the T1 is also updating the database, or the T1 also don't know the T2 is also updating the database, right? That is called as the isolation. Now durability, after a transaction completes successfully, the changes it has made to the database persist even if there are the system failure. Durability, if for example we stored our data with a replica, that is the server 1 and the replica server 2, right? If server 2 crashes, then we have data under the server 2, right? Server 1. If server 2 crashes, we have data under the server 1. That's called the durability. It's a maintaining the database, right? Or it may be the if any transaction executed and the in between the system fails, the transaction maintain the data properly. That one is also a scenario, and that's called as the durability. It's a 4 properties of each transaction should be maintain these 4 properties. We can call as acid property, right? Then this one is simply then go with the simple example. That one is a transaction example. it's a RA, means a read A value, like A is a account detail of a user 1, that is 1k, right? Then change the value, or we just to deposit the 500 here. Now it make it A plus 500 is a 1.5k, right? Now write is again write the 1.5k under the database. Then again read B, we have again a B value, B second user balance, that one is a B is equal to B minus 500. Now it end the transaction, this is simply the whole is a transaction, and commit it's a says that it's a final. Now atomicity, all or nothing, words it may be it execute the all the statement up to the commit, or nothing will be happen. That's called the atomicity. It maintains the atomicity. Consistency, no violation of an integrity constraint, like rule database was consistent before and after the transaction. It's a similar after and similar. It's not about the similar. It consistent, like some one of the user access the value of some variable as a 5 and some of the accessing as a 4 is a inconsistency. Consistency means what? All the user access the value of x as a 4, then we can say that it's a consistent. Now the isolation, concurrent changes invisible. It's a concurrent execution of a 2 or more transactions should not cause any inconsistency. Individually it may be the T1 is working, then T2 will be the stop or not access the database or not doing anything. That's called the isolation, individual process. Like T1 do the these two operations, then T2 is going with these two at the same time. T1 is nothing to do on the database. That is simply the isolation process. Now the durability, committed update the persists. Then when the commit query runs, a result never be lost because of recoverability using the RAD, redundant array of independent. This one is again a new concept, or it may be something concept which one is maintain the durability, maintain the data if the system fails. We have alternative location to retrieve the information in case of a crash, right? That one is a redundant array of independent disk. So this one is simply the example of the ACID properties. Now in next lecture we will know about the next concept. That one is a basic concept of transaction is done in this lecture. Now in next lecture we will go with the next concept. Thank you.